Okay, so now that you have seen how to use sum and difference of angle identities, now I want to try one that's got a little bit more going on. Tangent is always a little bit harder, or I should say usually a little bit harder than the other two. The other thing that's thrown in here is you also see radians instead of degrees. Remember, they're the same, we just need to figure out the same thing. So if it's kind of hard to navigate fractions and adding and subtracting and figure out what equals pi over 12. So what I would suggest you do is actually convert this to degrees and then figure it out. So it's a little bit easier then. So the stuff on the right, ignore that for now. I just did some extra figuring ahead of time. So I'm going to convert this to degrees. So remember, pi over 2 radians. I want to convert this now. I can use anything really, but pi radians is the same as 180 degrees. So I'm going to use that. And I want to convert it to 180 degrees. Or I'm sorry, to degrees. So I'm going to put the pi down here and the 180 degrees right here. The pi is the radians, and those will cancel out. So then I end up with 180 degrees divided by 12, which if you do that is 15, and now I'm in degrees. So really what this means is this right here is just tangent of 15 degrees. Okay, so now I want to come up with what are two values that are on my unit circle that could add to be 15 or subtract to be 15 degrees. And now it's a little easier to figure out. So you could do some subtraction or some addition. Actually, in the addition here, you would have to use a negative angle. That might confuse you. So it actually might be a little easier to just say, well, 45 minus 30 is 15. So that's what I went with here. So then we have a subtraction one going on as well. So this is tangent of 45 degrees minus tangent of 30. Again, you could come up with any two as long as they add or subtract and then just use the appropriate formula. So I'm going to now be using this one. To use this, you're going to need to know what tangent of 45 degrees is and tangent of 30 degrees. You can see in the formula you're going to need those things. So 45 degrees is pretty easy. Tangent, remember, is y over x. So if we look here, square root of 2 over 2 divided by square root of 2 over 2, that just gives me 1. So tangent of 45 degrees is 1. Tangent of 30 is a little bit more work. So that's 1/2 divided by square root of 3 over 2. So that's what I wrote right here. And then I went over there and just did a little math there to figure that out. Make sure you rationalize the denominator. If you need to pause the video for a second to see how I got that, go ahead. Otherwise, I'm just going to move to the next slide and come back and reference those. Okay, so we said that this is tangent of 15 degrees, and we are going to use 45 minus 30 to get us to 15 degrees. So now I'm going to follow what the formula says here, and I guess I'll use that color there. So we have tangent of 45 degrees. I'm just writing this formula now with my appropriate things here. Minus tangent of 30 degrees. Ooh. Okay, that's a degree symbol. Plus tangent of 45 times tangent of 30. Yuck. Okay, my writing sucks right now, but whatever. All right, so now we said that tangent of 45, again up here, is 1. Okay, and tangent of 30, we ended up with square root of 3 over 3. So I'm going to replace those values with what I've got here. Okay, I guess I should put my pen. There we go. Tangent of 45 is 1. Minus tangent of 30 is square root of 3 over 3. This here I have 1 plus, now remember you got to do this multiplication first, but tangent of 45 is just 1, and then tangent of 30 is square root of 3 over 3. Okay, it's kind of hard to read. So really what I end up with is minus 1 minus square root of 3 over 3 divided by 1. Make sure you multiply 1 times square root of 3 over 3 first before you add, so this would be 1 plus square root of 3 over 3. Okay, so now there's actually a lot to figure out with this, so I'm going to go to the next slide and figure this out. So, okay, so we have 1 minus square root of 3 over 3. So really, to be able to simplify this, I have to convert this and subtract if I can. So 1, I need a common denominator. So 1 is 3 over 3. So that would be the numerator right here, another way to write that. So now the denominator would be 3 over 3 plus square root of 3 over 3. Okay, so now I have a common denominator. So this is 3. On the top, it's 3 minus root 3. Okay, and then on the bottom, I would have 3 plus square root of 3 over 3. Okay, so now I've got this mess. So now I'm going to write, I'm dividing, so I'm going to multiply by the reciprocal. Okay, so when we do this, the quickest thing to do, I guess these you could cancel out right away to make your life a little bit easier. And then you have that. Okay, so now it would be great if you were done here, but we got a problem, don't we? We've got this in the denominator, and we can't have that, no radicals. So now if I have two terms, you have to go back to your radical unit. If you have two terms, you have to multiply this by its opposite. So we call that a conjugate. So we are going to have to multiply this by 3 minus root 3 over 3 minus root 3. Make sure it's on the top and the bottom because it's a special form of 1. You can see this one's got a little more going on. So now I'm just going to distribute on the top, distribute on the bottom, and simplify. So I'm going to give myself a little bit of room here. Okay, so let's work on the top here first. So, okay, so 3 times 3, 9. So now I'm going to do 3 times negative root 3, which would give me negative 3 root 3. Okay, so now I'm going to take negative square root of 3 times both of these. So that would give me negative 3 root 3. And now I'm going to do negative square root of 3 times negative square root of 3, which would be positive square root of 9. Okay. Let's do the bottom. So I'm just going to distribute again here. I get 9 minus 3 root 3, and then plus 3 root 3, and then minus square root of 9. Pause if you need to see where that came from. Okay, so now I'm going to simplify this. Okay, so this 9 is not going, nothing's going to happen there just yet. These two, when I put them together, remember they have the same radical, so I can add or subtract them. So negative 3 and negative 3 gives me negative 6, and then root 3. This right here is just 3. Okay, now the bottom. On the bottom, I've got 9. Negative 3 root 3 plus 3 root 3 cancels out. And this right here again is just 3. Okay, so I'm going to go right over here. So now I can put these two constants together on the top. 9 plus 3 is 12, and then minus 6 root 3. Now the bottom, here I have 6. Whew. Okay, so now, problem. I still remember I can reduce this, so 6 can go into all 3 of these. So 6 goes into 12 twice, goes into 6 once, so I don't need to write 1 root 3, but I can write that. And then I have a 1 on the bottom. So my answer here would be 2 minus square root of 3. So you can see there's quite a bit going on, and a lot of it has to do with your familiarity with radicals in our radicals unit. So again, go review those if they don't make sense, or ask me if you've got questions. Okay, hopefully that makes sense. It's a little bit more involved problem. Review it as you need to. All right, see you later. Take care.